Hey everybody, by the end of this video, you will be able to do electron configurations for many of the atoms on the periodic table. And so electron configurations show where each electron is in any atom. Okay, so in order to do this, we have to know how to count electrons in an atom. For me, this is one of the most fun things to do in chemistry. It's pattern based. The periodic table makes a ton of sense once we get through this, and there's just a lot of neat patterns that happened, or that happened because of electron configurations. So before we get into actually doing electron configurations, let's just talk briefly about a little bit more vocabulary. Okay, and we need to know what the ground state is. Okay, the ground state is when the electrons are arranged in the lowest possible energy position. Okay, and so typically in most of the atoms, an electron is in the ground state when the electrons are closest to the nucleus. Okay, and so when we assign electrons positions or places, we're going to put them in the ground state. Okay, we can move them around and put them not in the ground state, but typically we put them in the ground state. Why do we do that? Because there's only one arrangement of electrons that has the lowest possible energy. And so there's only one ground state configuration of electrons. And then the opposite of ground state is excited state, and that's when the electrons have any other arrangement that happens to not be the ground state. So the electrons could be further away from the nucleus or occupying a different orbital than they should, and so there are unlimited number of excited state configurations for electrons. So the one that we typically spend the most time on is this guy right here. Okay, the ground state. Okay, and you believe it or not, you've already figured out a lot of this, like what it does. Okay, and so when we add energy to electrons, they move around. Okay, and how do we add energy to electrons or to atoms? We can use heat or light or chemical energy, or actual physical energy adds energy to electrons. We can add electrical energy. Okay, and so when you add energy, the electrons will move up or into an excited state, but electrons want to be in the ground state, so they go from being in an excited state down to a ground state all by themselves. And what happens is you see the energy emitted. Okay, spectroscope here. This is, I think, just a regular white light bulb, like an incandescent light bulb. Not one of the twirly ones, but like the old style ones. And so this guy here, this is what you see. Okay, you see the electrons moving up in energy and then back down. And when they move, okay, I'll draw a little picture. Here's the planetary model. Okay, and so we have an electron here. We add energy to it, and what did we do? We plugged it into an outlet and turned on electricity to it. So we added electrical energy. The electron moved up, and then instantaneously it moved back down. Okay, and then that electron moved up and back down. It took the energy from the electricity to move it up, and then it moved back down. That energy, remember, E equals h nu, the frequency. This tells us what the energy going from the electron moving from this to this, or if we have a third one, the electron could go out to the third one. So in this case, we're seeing 1, 2, 3, 4, 5, 6 different electrons 6 different movements of electrons. Okay, here it's so broad because we have so many different things moving around that it's going everywhere. But now that we see this, though, it's kind of neat. But let's get into it. Okay, and in order to do this, we need a periodic table. Okay, so let's talk about hydrogen. Okay, we're gonna get hydrogen. We're gonna do hydrogen. We're gonna find its electron configuration. Okay, we're gonna put hydrogen's electron. It has 1 electron. We're gonna put hydrogen's 1 electron in some place. Now, when we put hydrogen's electron someplace, we want to put it in its ground state. What is the lowest energy shell that's out there? Well, the lowest energy shell is the 1 shell. Okay, and it turns out in that first shell can only have 1 subshell. So it can only have an S subshell. And then one of the things we skip over is the orbitals, and then how many electrons go into that S orbital? 1. So what we have done is we have made our very first electron configuration. We have put the electron in the 1s, and then this is the 1 electron. So it's 1 electron in the 1s orbital. Okay? Now, let me delete this. Let me get rid of some of this stuff from what we did, right? Hydrogen is over here. Okay, hydrogen being over here. It's kind of interesting, hydrogen being over here. Notice it's in the first row. Okay, well, that's interesting because in the first row, I think that we're saying that that's the first energy level, and it's over here on the periodic table, and I think this is the side that only has 2 is 2 elements wide, and I think that that's the S part of the periodic table. And then where is it? It's in the first column, so there's only 1 electron in there. Okay, now I will tell you, if you don't get this right now, please keep watching. Please keep looking, because the pattern will eventually fall out, and eventually you'll be like, oh, I get it. When you get it, you can't unget it, you can't unsee it, and it becomes powerful. Okay, so now for helium, how many electrons does helium have? Okay, neutral helium. We're not talking about ions. We're not talking about crazy numbers of well, if we look at the periodic table, it has 2 protons. So because it's neutral, it'll have 2 electrons. Okay, so we need to put those 2 electrons someplace, and they need to go closest to the nucleus. So if they're going to go closest to the nucleus, we're going to put them in the first shell, and in the first shell, there's only an S orbital, and how many electrons can go in the S orbital? 2. Okay, and there we go. We've put all the electrons that are in helium, all 2 of them, someplace. So the electrons are in 1s2. Okay, that's where it goes. Now, lithium. Lithium's a little different breed here. Lithium is here. Lithium has 3 electrons. Notice what row it's in on the periodic table. It's on the second row of the periodic table. Okay, well, the second row, notice it has a lot more elements in it. Well, the second row has these guys on the S side, but notice it also has these guys over here on the P side, okay? Okay, well, let's talk about lithium, okay? How many electrons does lithium have? Atomic number 3. So now we're going to put those 3 electrons someplace. And again, we have to start closest to the nucleus. The nucleus here, I'm just going to draw half of a nucleus, or half of a shell here. And so what we know is that the shell closest to the nucleus can only hold 2 electrons. The first shell can only have an S orbital, 1s, and it can hold 2 electrons. Now, in order to get to the third electron, in order to put the third electron someplace, we have to go to the second shell, or the second energy level, and now we have to start back over with the s's. Well, how many electrons can go in the s's? Well, up to 2. Well, we only have one more to put someplace, so now that's going to be 2s1. Now, look, here it's in the second energy level. The outermost electron, where did we stop? 2s, this was the s side of the periodic table, this was the p side of the periodic table, 2s, and notice we're on the first column. So that's kind of interesting. Okay, well, let's look at beryllium. Beryllium has 4 electrons. Okay, we're not going to go through the whole periodic table like this, trust me, but I want to build up the pattern. Okay, and so now beryllium is right here. Okay, it's in the second row and it's in the second column. I wonder if that's going to be any pattern. Well, again, where are we going to put electrons? We're going to start closest to the nucleus. What's the closest to the nucleus? The first shell. Within the first shell, there's only an s, and we can put 2 in there. And now we have to go to the second energy level. There's not a lot of space around this first one here. So now we can go out to the second energy level. And I know that I'm drawing not the cloud structure, but I think that this is easier to draw. But anyways, we go to the second energy level, and we start back over at the s's. Now, how many electrons can we fit in that spherical shape? Well, we can put 2. Well, we've put 2, 4. We've put our 4 electrons someplace. Now we go to boron. Boron, notice boron has 5 electrons and it's over here. Okay, well, let's do this up. 5 electrons. Okay, so we want to put the 5 electrons someplace. Well, we're going to start closest to the nucleus, ground state. So we're going to go 1, and then that first energy level has just an s, and we can put 2 electrons. So 1s2. And now in order to put the rest of the electrons in there, the 3 that are left, we're going to go to the second energy level. So we're going to go 2, and then again, the lowest energy level subshell within the second shell is an s. And how many electrons can we put in the s? 2. But now we've put 2 4 electrons in there. What do we do with the 5th one? Well, the second energy level, or the second shell, has not only s's, but it has p's. And this is reflected in the periodic table because here's our s's, and look, in the second energy level, we have p's. We have these guys all floating around. And I'm conveniently ignoring helium. I'll get back to that. But look, the p's are right here. Notice that the p's don't start until you get down to the second energy level, or the second row on the periodic table. Okay, so now where are we going to put them? We're still going to be in the second energy level, the second shell. Those 2 words are synonymous. They're synonyms of each other. And then now we're in the p's, which have slightly higher energy than the s's, and we're going to put 1 in there. Now, how many electrons can we put in the p's? Well, how many orbitals do the p's have? The p's have 3 orbitals within them, so we can do up to 6 electrons in the p's. Okay, well, let's keep going. Carbon has 6 electrons. Okay, we want to put them someplace. Again, we're building it up. We're starting closest to the nucleus and working our way out. So we go 1s2, and now the first shell is filled. So now we're going to go to the second shell, 2s2, 2p. Now, how many electrons have we put someplace? 2, 4. How many electrons do we have left? 2p, 2. We're going to put 2 more electrons in here. Okay, so now we've placed in here a total of 6 electrons. That's how many carbon has. Nitrogen, neutral nitrogen. Okay, just to reiterate, atomic number is 7. We're talking about a neutral atom, so that's 7 protons, so there must be 7 electrons. So what are we going to do with the 7 electrons? Well, again, we start with 1s2, 2s2, 2p. Now, again, how many electrons can the p's hold? Well, there's 3 orbitals each orbital can hold 2 electrons, with each with a different spin up and spin down. And so if we can hold 6 in the p's, that means that we can go up to 3 here. Okay. Now, is there a coincidence that this is the 1, 2, that nitrogen is the third element over in the second row over on the right-hand P side of the periodic table? Is that a coincidence? I don't think so. Okay, so now we go to oxygen. Okay, so oxygen has 8 electrons. Okay, so we're going to let's put the 8 electrons somewhere. Okay, 1s2, 2s2, 2p4. Okay, what if we go to fluorine? Okay, fluorine has 9 electrons. Okay, what do you think? Maybe pause the video, come up with an idea here. Okay, let's see. So 1s2, 2s2, 2p5. Conveniently, notice that fluorine here with 9 electrons is the, let's see, 2s12, 2p, 1, 2, 3, 4, 5. It's the 5th one over on the periodic table. Okay, well, there's all sorts of other patterns that we can do here on the periodic table. Let's expand. Let's go to different elements. Let's go back and forth here. I think it's important for us to do that. I'm going to move forward here, and then I'm going to wait for this to open up. Okay, and it'll be good. Let's go, because this is awesome in the way of doing this. This is the single most excited I get over teaching patterns on the periodic table. Okay, so let's go. Okay, yeah. Okay. I thought when I was making this that I was going to stop at oxygen and then do another video on like some other ones, but you know what? I'm on a roll, and we just keep going. Okay, so now let's take a look at sodium. Now, sodium has 11 electrons. We have to put those electrons someplace. Now, I am able to go back and forth here. I'm going to show you my periodic table here. Okay, so there's the periodic table. Here's sodium right there. Okay, 11. Notice that's in the 3rd row on the periodic table. Well, that is convenient. Okay, let's start filling electrons. 1, okay, 1s2, 2s2, 2p6. Great. 2, 4, 10. We've put 10 electrons somewhere. Now, where do we put the last electron? It's 11 electrons. We need to put that 11th electron someplace. There's no room. Remember, the first energy level, the first shell, only has S's. The second shell has S's and P's. Guess what the third shell has? S's, P's, and D's. Okay, so now we've done here. We filled the S's, we filled the P's. Now we need to go to the 3rd energy level, because that's the next lowest energy spot. And so we're going to go to the S's. 3s1. Okay. Now, what if we go and I'm not going to go through all of them, but let's go to sulfur. Okay, sulfur, element number 16. Okay, so element number 16, sulfur, 16 electrons. Now, again, 16 electrons. We're going to start at the lowest possible place to put electrons in there. 1s2, 2s2, 2p6, 3. Now let's just go backwards. Sulfur's right here. Notice it's in the 3rd row. So let's see, we've gone through the S's. This side is the S side. Remember, there's only 2 electrons that can be in an S orbital. It's convenient that this tower of the periodic table is only 2 elements wide. And remember, the P's can hold 6 electrons. It's convenient that this side of the periodic table, this tower, the 2 towers, the second tower here, is 6 elements wide, and it turns out that sulfur is the 4th element over. Okay, so let's see. So we've gone through the S's, S2, 3, P4. Okay. Now, what if we go to calcium. Calcium is element number 20. Okay? Now, calcium, we can use the periodic table to do this, okay? Now, this is where the things start getting funky, okay? 20 electrons in calcium. So, here's what we're going to do. We're going to start 1s2, 2s2, 2p6, 3s2, 3p6. But where's calcium? Calcium is here. It's in the 4th energy level, and it's on the s side. But you're saying, hey Walsh, we filled the 3 p's. Shouldn't we fill the 3 d's? Well, s, p, d, f. It turns out that, what does ground state mean? The lowest energy levels get filled. So it turns out that the 3Ds have slightly more energy than the 4S's. So regardless of what you call them, 3D or 4S, you're going to fill the lower energy levels first. And so by filling the lower energy levels first, you fill the 4S's. And so you fill 4S before you fill the 3Ds. Okay? And that is the thing. So now when you move along and you go to something like iron, okay? And I know I'm on a roll here. So iron, element number 26. Okay, we'll look. Let's scroll down here. Iron, element number 26. So Fe, we have 26 electrons. Okay, and this is the beauty of the periodic table. This is why the periodic table to me is so awesome. Okay, I can't explain that enough. Okay, again, we're going to go 1s2, lowest energy level first, lowest energy electrons first. So we're going to start at 1s and we're going to fill the 2. 2s, we're going to fill the 2. 2p6, we fill the 6. Okay, 3s2, 3p6, and now look where it is on the periodic table. Iron is here. The periodic table tells us how to fill the electrons. What happens first? Well, we fill the 4 S's here. This is the S side. But then look here. This is the first time we see D's. This is the D block. Okay, so if this is the first time we see D's, in what orbital, or sorry, in what subshell, what shell do we see D's for the first time? The 3Ds right here. So this first level must be the 3Ds. This has to be the 3Ds going all the way across here, because that's the first time that we see Ds. And so we do that. So now, if we're going to fill this, it's going to go 4s2. That's what the periodic table tells us. And now we're going to fill the other 6 electrons into the Ds. The Ds go in, but they're the 3Ds, 3d6. Okay? So, filling electrons, super important. And we're going to do a different version of this in the next video. That different version is going to be like energy level diagrams. So stay tuned and watch it.